Step 7-1. Analyze the malware in 7.1.exe. So, I already went into Resource Hacker and there's nothing there. PE view is a good one. We see that there's calls to create a service, start a service. There's a timer. Create a mutex, open a mutex. Sleep. Load library and get proc address indicate process. Well, that happens sometimes in process injection, or is used by process injection. And then so when inet to open a URL and get a page or something like that. Okay, so strings. Okay, we see a host-based or a network-based indicator here. It's a URL, and this could be potentially a user agent. Then we see a bunch of imports on the DLLs. Some error messages don't make a whole lot of sense. So I'm going to go ahead and run the program. Process Explorer, show lower pane. There's a lot of threads sitting out there. I saw that HGL 345, looks like a mutex name. That's a good host-based indicator. I don't know what else to make of most of this. But let me open. I just killed the process. I'm going to open item free. Hit spacebar so I get to this. Looks like there's a service. It's called Malservice. That's another good host-based indicator. There's that mutex name. So it tries to open the mutex. Then it has this test here. If it's 0, it jumps to this. So 0 means it doesn't find the mutex. If it doesn't find the mutex, it continues. If it does find the mutex, it exits. So if it doesn't find the mutex, it creates it. So that's sort of like a lock. If it sees one out there already, then it will restart. That guarantees that only one of these processes will be running. See what else we have here. Create a service. According to the answer, this should wait until the year 2100, and then what it does, and then to perform its action. So that's where this January 1st, 2100. That's where it comes from. So it looks like it's moving 0 into, well, W here is, it gets 0, but later on it gets 2100, so it doesn't matter. Day a week, hour and second all get zeros. Decrements, and if it's not 0, it jumps back up here and it keeps decrementing. That's 20 times it goes through the loop. So it will create 20 threads. And what this thread does, I'm not sure. I think this is where we find out. Okay, so that Internet Explorer 2.0 string we saw is a user agent. The internet connection. It attempts to connect to malwareanalysisbook.com, and then I guess that means it keeps trying to connect to it. And if you have 20 processes doing that and they never end, well, that sounds like a DOS attack. Denial of service attack. Okay, so back to the questions. How does this program ensure it continues running? It started as a service. Why does this program use a mutex to guarantee that it's only created once and running once? What is a good host-based signature? Well, we saw the mutex name, and then we also saw the service name, Malservice. What is a good network-based signature? The user agent isn't real unique. This is probably not good, but this may be unique enough. The address, IP address, or URL. What is the purpose of the program? Denial of service of a website. When will this program finish executing? Never. Lab 7-2, analyze malware found in the file lab72.exe. How does the program achieve persistence? Excuse me, what is the purpose of this program? When will this program finish executing? Okay, so I'm going to start by running strings on it. So what I see here is a URL, which may be a good host-based indicator. Or, I'm sorry, I always get that wrong. Network-based indicator. Other than that, I don't see much. I go into PEID. Doesn't look like it's packed. Go into PE view. Look at imports. So we have these are ordinals. So I'm going to have to go in. I think Dependency Walker will be better in that respect because we can do the linking for those ones with ordinal only. Okay, so these are related to COM objects, I guess they're called. Back if we look at page 154, the component object model, COM interface standard that makes it possible for different software components to call each other's code without knowledge of their specifics of each other. So, let me see what else we have in here. So if we look at this, 2, 6, and 8, that'd be sysallocate string, sysfree string, and variant and knit. I don't know if those are referenced in this chapter. I'm looking. I don't see references. MSVCRT is a common C programming language, DDL. There's not much use. Well, we can't gain much information from what we see there, so I'm going to go ahead and run the program. Okay, it brought up this right here, malware analysisbook.com add. So I assume that well, what this is doing is this is going to inetsim, and this is the default returned web page for inetsim for any HTTP excuse me, for any port 80 call to any site. It comes back with this because I'm not connected to the internet. So anyway, right here what we have is this is the inetsim address, and I'm in APay DNS, which and also under networking I have it set up to go to that inetsim box. So anyway, let's open it in IDA Pro. Okay, so let's see what we have here. OLE initialize, that's related to COM objects. This is co-create instance. Somehow sysallocate string is related to it's unclear what it's doing with those functions. OLE initialize. But we can gain more information. One way that I found more information was to go into, I'm going to hit spacebar and then go look at, there's a couple we can look at here for the component object model, is before co-create instance. There's an RRI or RIID. In addition, there's other objects we can look at, CL, SID, and IID. So we can find information about that. Now, what I did was I went online and looked after I obtained the strings that were at those locations. Let me head back. We're scrolling down a little further here and see where spacebar. That's not giving me what I wanted. Somewhere I can get the CLSID. There's a mention that you can add standard structure pressing the insert key, but it doesn't work for me here. This right here, offset CLSID. Then we have well, I can type it in. This is a non-standard method to, it's not recommended in the book as to how to, you know, do a search on the internet, but I got the information I needed. I mean, I went in and I looked, and this directly relates to the problem we have in here. So what it's doing is the COM object calls initialize, and then the registry keys are there. I'm not going to go and look them up because it takes a lot of time, but you could look up this key, and it's sitting on the system, as is this. So if you look further down, let me see, what did I type? 2DF01. Let me go back here. That's right here. 2DF01 corresponds to Internet Explorer, and then RRID is this number. And if you go back over here, it's right there. Double check. Yeah, that's the number. So that leads us in the right direction, and this is doing the same thing. The navigate function is used to browse to that web page using this COM object, Internet Explorer web browser. Okay, so back to the questions. How does this achieve persistence? Well, it turns out persistence is not achieved. Hit the back button. There's nothing creating a service or dropping a DLL or anything like that, or editing a file. What is the purpose of the program? Display an advertisement. When will the program finish executing? Well, it's not executing right now. It's already done. That's it. Okay, we're on Lab 7-3, and this is a whopper of a program. It's a great example of probably what you'll see in the real world, I'm sure. But I mean, to understand it the first time through is difficult. I didn't, so let's take a look. There's a lot of code in here that should really be skipped, and one of the points the author makes is don't try to evaluate every line of code because it just will take too long. I missed important clues on this one. I couldn't get it to run. I probably should have been able to. But apparently it takes a command line argument. Let's start with Lab 703exe strings. Okay, we have in here, you know, the usual garbled stuff at the top, then imports, the DLL names. We have a Kearney 132 DLL, and then we have a kernel 32 DLL, so that's an imposter program, or imposter DLL. Now, I missed this exe. I didn't think it was important. It doesn't look important, but it is. It's key. Let's see what else. This is another important thing. Warning, this will destroy your machine. I thought, well, that's a message that might display when you run the program. Okay, so I'm gonna run this same thing for DLL. We have the garbled stuff, imports. We have an IP address, and that's important. That's a good network-based indicator. And then it's hard to make what it's doing here. Looks like it might be able to sleep. Now it's going to Dependency Walker. Okay, so create file mapping. That means it may change files or inject, process injection. Find first file, find next file, maybe looping through files. And then MSVCRT has to do with C programming language functions, so that doesn't help us too much. Now let's open DLL. Okay, create a mutex, open a mutex. It may keep itself from running more than one time, like we saw in 7-1. It may sleep, and then this is all internet connection related functions, socket, and then again the C programming language DLL, not too useful for us. Resource hacker, there's nothing in there. So let me open item pro free because, well, first of all, if I run it, double click, it didn't do anything. I checked logs and everything, it doesn't do anything. So open. In addition, I recommend you read the whole answer. It's a very long answer, maybe 10 or 12 pages. But it probably really gets into how, you know, the standard real malware looks and acts. So let's see. I'm going to go into the executable. See what this thing does. There's that warning that I thought maybe moves the offset to ESI. See, it's doing something, but it's easy to lose track of what it's doing with all that code. But when you get down here, let's see if there's any if statements. Actually, this may be the one where it checks. Check that. Somehow it exits, and I'm not sure how. If it's not equal to a warning, this will destroy your machine. In the answer. Let's see what we got here. Well, I'm going to go back to the book, the answer, and follow its methodology, which is go into the DLL and find out what it does. It's simpler. So once we know what it does, that will help us really understand. Okay. It opens a mutex, and if it doesn't exist, then it creates it. That ensures that only one program is running at the time. The process is only running once. Let's see what else it does. You say startup. Usually the green means success in performing the operation, but red in this case appears. What that means is jump not 0. If it is 0, then that means WSA startup had success. We come looks like it might send the word hello through a socket. And then if it fails, I assume shutdown occurs. I don't know what to make. The shutdown, what it does isn't clear, but I don't think it closes the connection. It may end the transmission descending. So then it receives information, and down here, because this error was in here. Well, I know from the answer that this doesn't do the sleep. I immediately thought when I looked at this sleeps. Now this is prepping for a sleep on this branch. If the command is to sleep, it goes and calls sleep for 60 seconds. Otherwise, it comes down here to exec. If the letters are exec, it goes this way. If it's not, it goes this way, which could sleep over here or close the handle, depending on something. Okay, over here it does a command line, which that's hard to parse, and apparently it's the 5th character and onward on the input, what's received. So anyway, that's that, but we don't know where it's called. Oh, in addition, imports. It does have imports. About exports. That's key in DLLs. We're going to export something else. Only the DLL entry point, which is non-standard. Obviously, it's malware, so you're going to get that in malware. So this DLL may be utilized somehow and then, or injected somewhere, and then whenever that program is called, it will execute this procedure to call that IP address, wait for sleep or exec, and then run commands. Okay, we're done with that. Onward. Okay, so apparently what this does is if you enter warning this will destroy your machine, then it will perform the function. I'm trying to figure out where the branch happens. I guess if EDI is not 0. Exit the program. Otherwise, come down here. Do this offset into ESI. Do some compares. This is where I'm skipping stuff that doesn't make sense, down to stuff that calls and stuff like that. So we're going to create file. So that this is open. This isn't just create, it can open an existing file, which is what it's doing here because kernel 32 DLL is existing. Maps the view of the file. As soon as something goes wrong with this, it's it's trying to open lab 73 DLL. Fails, it exits, maps the file, continued mapping stuff, a whole lot of, I don't know what. There's no imports being called, so I'm skipping. Okay, now we're to close handle. Down here at the bottom. So it looks like this copy file will put lab 0703 DLL into C Windows System 32 Kearney 132 DLL. So the imposter Kearney 132 DLL is actually lab 73 DLL. Now, this sub is a big deal when you go into there. And what it's doing is, but there's a recursive search of all exe files. That's what this does. Okay, so we don't know what it does. It's looping through all the programs, the exe files. But what I want to do is, as recommended, run this lab0703.exe, and then with that string, this right here, warning, this will destroy your machine. So I'm going to type lab0703.exe, warning, this will destroy your machine. Alright, now I'm prepping everything. Okay, so got process monitor running, red shot, got the first shot, EPA DNS is good. Process Explorer, I think this is going to be key. This program runs for a long time. Enter. I'm going to go ahead and press enter over here. And it might not have typed it right, but we're going to find out shortly. Okay, it's running. It hasn't stopped. Lots going on. There's a lot of events coming through. Okay, I'm going to stop here, and then when it's done, I'll come back. Alright, I'm back on 7.3 and the program completed. And I'm trying. Let me open something, just any executable in here. Any. Let me open this one. This. That says Kearney 132.dll. Now, it used to say kernel 132. So if you go into any exe on the system, you're going to see that. The fact is, I thought I would have seen it call out, and I didn't. But I'm not going to dwell on that too much because I've spent a lot of time on this, and I don't fully understand it. It'd be cool to get the full functionality working though.